up guys, Fire here from Untold.com. You like the new look, don't you? You like the new sexy glasses? It shoots a sexy laser light beam. Anyways, welcome back to another tutorial. This time we have a really cool, let's say somewhat a hyper casual game for Android finally, because you guys are like, create an Android game, and I created an Android game. Okay, I'm listening to you. So before we do anything, let's take a look at the game that we're gonna create and smash the like button. So what I'm gonna do is I'm gonna run the game and we are gonna see what we have. So here we have this sheep, we have these platforms, we can hear the background sound and all of the cool stuff, and we can move the sheep. As you can see, I can move it with my mouse. Now this is touch input in our mobile or on our mobile phone. So when I click on this platform, this one will rotate. We need to get to this white thing that I don't know what this is. Anyways, it's a white thing. So we get to it and voila, we load a new level. Now here we have this is another level where we need to put these puzzle pieces together. So we need to click or go over here where this red thing is. Then we can click on this button. So another platform will come to us so we can finish our game. Basically, it's a platform game. Now this is how it is played on mobile, or actually, excuse me, on computer. And now I'm gonna put mobile on the screen, so you're gonna see me playing that game on mobile as well, and we're gonna see how we're gonna transfer the game on the mobile device, what we need to do to achieve that, and how can we create this game, well, to play it on PC and on Android as well. So smash the like button, and of course you can download the assets in the complete project. Link will be in the description below if you want to. I hope that you understood what I said. If you want to follow the tutorial, you can download the assets and smash the subscribe button as well. And let's get into the video. Okay, you know the drill. I am in a new project and I named it Puzzle Tower. I added tutorial project, but you don't need to do that. You can name it however you want to name it, by the way. Anyways, it's a new project. It's a 3D one. So let's import the assets, which are right here. So I have the model, sounds, and sprites. So I'm going to select all of them and simply drag and drop them right here. And you can, of course, download them. Link will be in the description below or on my website. So, of course, we also need to wait for Unity to import these. Unity is kind of torturing us. But, hey, before we try or start doing anything, what I'm going to do is I'm gonna go here in the scenes, and the sample scene, I'm gonna change it to level 1 scene. So this is the name of our level. So yeah, level 1. Simple as that, nothing complicated. So moving forward, what is the next thing to do? Well, now we can go into the models and we have here our levels. Now, of course, these levels, they have these shapes and materials and all of the good stuff. Let me just go here and see the model. So this is one of the models, as you can see here. Let me select this big, this sheep. So we also have it right there, but yeah, we're gonna use this sheep right here. But don't worry about that. The point here is we have multiple parts of these levels. So if you go here in objects and platform, so here you have these platforms, you get the point. So what I did here is in the prefabs folder, we have all of these levels pre-made. So this is the level 1, and I'm gonna drag and drop them one by one. So we have the entrance platform, we have the large platform 2, and the moving platform, and voila. So these are the platforms, as you can see here. Now, where is the entrance one? Yeah, here it is. So over there, you see, over there is the entrance platform, this one right here. Now you get my point. So this is our level. Instead of us stacking everything one on another and configuring all of this here, which takes a lot of time, you see, adding colliders, adding all of the good stuff, what you can do is you can go and inspect these, but basically these are only those game objects put together to create this level, and also they have colliders and stuff to help us, well, play the game. So this is our level 1. What is the next thing to do? Well, the next thing to do is go here in the prefabs and actually not level 2, but in models and sheep. Here it is. So we need to drag and drop the sheep, and yeah, it's right here. And if I zoom in on the sheep, basically it's very small. As you can see, we cannot even see it. It's so small. Yeah. So this is the sheep in comparison to our level. We cannot even see it on the camera. So if I take the camera and set it at Command Shift F to change the position. As you can see, we don't even see the sheep. And if I zoom in, you see this white dot right here, that's the sheep. By the way, if you want to have the camera like this, you see it's in portrait mode because this is an Android game. What we need to do is go in the game tab, and right here you have this drop down list. Now, of course, you will not see this 480 by 800. You will need to create it. You can create it by clicking on the plus button right here. I think your resolution is going to be something like this. So you're going to click there where it says free aspect, depending on if your build is set here, not build and run. What am I doing here? So let's go here and build settings. So if the build is set on PC, Macs, and Linux, then you will see here free aspect. Otherwise, I don't know, I don't care. Anything that you see here, you're gonna click on it. So click here, go on the plus button, and here you're gonna label or name your resolution. And this is not New Year's resolution, so don't get caught up into that. Don't be confused. New Year's resolution was, you know, like 3 months ago, so you're late now. Don't make any resolutions. Anyway, lame joke, I know. Anyways, width and height is here, so you can set the width 480. So it's 480 by 800. Click OK, and voila, you will have that resolution. You can click on it, and voila, there is your resolution. Now, of course, you can also delete it by right-clicking on it. You can delete it or edit to change the settings if you're not satisfied. Anyways, moving forward. So here we have our sheepy sheep. What we're going to do with the sheep is, first of all, we are going to resize it. Let me zoom in on the sheep. So this is our bad boy. What I'm going to do is take the x-axis and set it on 25. That is for the scale. So scale for X, Y, and Z is gonna be 25 on all 3 axes. And let me just set him at the position 0, 0, 0. Why isn't he set here? 0, voila. So this is our sheepy sheep, as you can see now. He is much bigger. If I go into game tab, we see him perfectly. This is what we want. So what is the next thing to do? The next thing to do is click on add component here and attach a rigid body, not 2D, but rigid body, because rigid body 2D is for 2D and rigid body only is for 3D. I'm still not sure why don't they change this to rigid body 3D. It will be, I think it will be more helpful, especially to beginners. But anyways, rigid body, click on it. Click on these constraints right here. So you have the constraints, and you're gonna freeze the rotation on X, Y, and Z. Freezing the rotation on X, Y, and Z will not allow the rigid body to rotate. Now we will be able to rotate on the transform, but not on the rigid body, which means we cannot apply torque and stuff like that. But that's also not important because we will use transform for that. But I'm just explaining what is freeze rotation. And the next thing that we need is go here and add component. We're going to attach a box collider, and voila. Now, for these values here, we're going to have a decimal point number because, I don't know, the model is like that. So what I'm going to do here is for the size X, I'm going to say 0.023, and the size Y, we can leave it like 4 point, I don't know, we can leave it like this. The size Z is going to be 0.03, and we also need to offset it a little. So let me just go here, and I think the center, so I think the center of the sheep for the X is going to be at 0. What is happening? So yeah, it's going to be 0. For the Y, well, I'm also going to leave it like this. And for the Z, I'm also going to set it at 0. And this is our collider for the sheep, as you can see. Now, the last thing before we save it as a prefab is go here on top and where it says untagged, right below the sheep name. Click on this untagged and click on player. The player tag is by default added when you create a new project. I think that started with Unity version 5. I'm not sure. But anyways, you will have a player tag here. If for some reason and some miracle you don't have it, you're gonna click here on add tag and you're gonna go on the plus button and you're gonna type here the player tag and you're gonna add it right here and click save. I'm crazy, I know, don't judge me. So now we're gonna go back in the assets right here. And actually, can I go here in the models and sheep? No, I'm gonna go here in the assets and create a new folder for prefabs. Like this, and here I'm gonna right click and create a folder for player prefabs, so player prefabs, and inside of this I'm simply gonna drag and drop the sheep, and I'm gonna click here. Would you like to create a new original prefab or a variant? I'm gonna say new original prefab because I don't care. I am like that. I break the law, and yeah. So what is the next step for us? The next step for us is to make the sheep move. In order to do that, it's coding time. You know, like Power Ranger, there's morphing time, it's coding time. Now you're transforming into a coder. So we're gonna go here and create a scripts folder, and I'm gonna go inside and right click and create a new folder, which is going to be player scripts. Inside of this folder, right click and create a C# script, and I'm gonna call this one player movement. So in the player movement, before we do anything, select the sheep and drag and drop it on the sheep game object. Make sure it is attached. For some reason, from the first try, I never managed to attach it's like something impossible that you can do in Unity. So yeah, from the second time, I always attach. Anyways, go on top, and where it says, you see here, we have default and you have these overrides, you see? Right below the prefab open, select, you're gonna click overrides and you're gonna apply all, because this change, and the change is adding a movement script to the player script, or actually player movement to the sheep. That change will apply to the prefab, to the original one. So double click here and open this in Visual Studio or in, I don't know, MonoDevelop or Notepad, or I don't know, your notebook where you're writing your code. So open this script. And what we are gonna do here, well, first of all, we need a rigid body because we're gonna use it to move the game object. So we're gonna say here, private rigid body RB. And this is not the music genre, RMB, this is just RB rigid body, don't get cocky with me. So private rigid body, the next thing that we need is a public float, and this one is going to be the move speed, which is going to be by default equal to 3. Now I set it to be public, that means we can change it in the inspector if we don't like the speed. What is the next thing? The next thing, we need a private float. So a private float, and this one is going to be our smooth movement. And this one is going to be equal to 15F. Now, you can assume for what we're going to use it, we're going to smooth out the movement by using or multiplying this value with time.delta time. So moving forward, we also have here a private vector 3, which is going to be our target forward like this. I have spelling problems. And here we're going to have a private bool, which is going to be can move, to indicate if we can move or not. And we are also going to have a private vector 3D position, which is, well, delta position for our game object. Now, inside of the awake function, you know, I'm in love in the awake function. So I'm going to say here, RB, or rigid body, is equal to get the component, which is the rigid body component attached on our sheep player game object, whatever you want to call it. The next thing that we're going to do is we're going to say this target forward is equal to transform forward, and we were going to see in a second for what we're going to use it, so don't worry about that. Inside of the update, and we are not going to use the start function, so remove it from here. I'm also going to remove this comment, and I'm going to go in the update and create update forward function, and I'm also going to create get input function. No, I'm not creating, actually, I'm calling them. And in the fixed update, not fixed joint, fixed update, and in the fixed update, I'm going to call move player. Now, of course, these are all functions that we did not create. So the first one is going to be void get input like this. The second one is going to be update forward. So void update forward like this. And the third one is going to be void move player. Okay, so now we don't have any errors. What are we going to do in the get update? Get input. I cannot read now. I have spelling problems and I have reading problems. So this is get input. And inside of this one, we're going to get the input from the mouse, which will also get the input from the touch. So here I'm going to say if input dot get mouse button down, and I'm going to say 0 here. Now, get mouse button down 0 will detect the left click on your mouse. So when you click, the left click, and down means when you click on it and hold it down. We also have get mouse button like this. It will detect when you press a mouse button, that is the left click, and 2 is the right click, or 1, I believe. I believe 2 is the right click and 1 is the scroll or the middle click. I'm not sure, but you can test that out. Simply use a print statement and print in the console depending on which button you pressed on your mouse. But 0 is definitely the left click. Anyways, get mouse button 0 will detect when we press the left click on our mouse button, and as long as we're holding it, it will call this function. So it will call this, will be true, it will be true, it will be true. But if we say down, that means only on the frame when we press down the button it will detect that, and only then it will call that function. Or input get mouse button down, 0 will return true only during the frame when we press it. All other frames while we're holding the button it will not detect it. So when that happens, we're going to say can move is equal to true, and it will be true for as long as we're holding our clicking on the left mouse click and holding it. But here we're going to say else if our input get mouse button up. And here I'm going to say 0. Now get mouse button up will detect when we release it. So if you pressed the left mouse button and then you released it, then this will detect that. So here we're going to say can move is equal to false, which means we're not going to move anymore. And all of this will happen in the update function right here, get input. Actually, I'm going to put the get input right here, the first function, and then we have update forward. Now for the update forward, we're going to update the forward. So we're simply going to say transform.forward, which is the forward of our, if I hover over, it says the blue axis of the transform in world space. What does that mean? That means if I go here, you see the blue axis. So come on, come on, come on. Sometimes Unity is slow. You see the blue axis? This is that blue axis, and it's forward. So forward basically is backwards for the sheep, but don't worry about that. We will fix it. So yeah, don't worry about it. I'm going to go here, and transform forward is going to be equal to vector3 dot slurp. Now spherically, or slurp will spherically interpolate between two vectors. That means it will go from one point, to put it in plain English, because I find that some of these functions are, it can be better explained. But basically, what does that mean? It will go from one point to another point. So it will go from transform forward. It will go from this point towards the target forward, and in time interval it will be time.delta time, and we're going to multiply that with the smooth movement. So this is what's happening here. This is what's going down, okay? So transform forward is equal to slurp. It will slurp from this position to this position with this time interval. Simple as that, nothing else. So let's say here we have value 1, for example, to paint a clear picture, and here we have a value 3, so it will go slowly from value 1 to value 3 in this time interval. Simple as that. So this is update forward. Okay. Spelling problems, you know me. And here I'm going to say move player. So move PLA, and I'm going to spell things now. So in our move player, we're going to test if can move. You see the wisdom behind the code that I'm typing? I mean, you can write books about my code. I don't know. I am in the mood today. So yeah, maybe tomorrow when I continue this tutorial, I will not be in the mood. So yeah, enjoy the jokes. Thank you. Input get mouse button down. So when we press and hold the mouse button during the frame where we pressed it and started to hold it, we are going to say can move is true. As soon as we release the button, get mouse button up, then we will say false. But for as long as it is true, that means we can move. So if we can move, what we're going to do? Well, here we're going to say delta position, so D position is going to be equal to, and we're going to say new vector 3, and here we're going to get the input from our mouse axis. But in order to do that, we need to create our helper scripts. So what we need to do actually here is this. So we need to say here vector 3, and for the x, we're going to say input get axis raw. And here we would say mouse x. So this is for the, mouse x. And for the y, I'm going to say 0f. And the next one here, let me just copy this. And this is going to be input get axis raw mouse y. So this is what we will need to do. But you know me, I hate these hard coding things. So we're going to create a helper script. I know in some of these videos I am, or I don't know, because what did I want to say? So helper scripts. In one of the videos, because I record a lot of videos and I don't publish them right away, I probably at the moment have at least, I don't know, 5 or 4 videos on pending. So videos that I will publish, so tag manager. Videos that I will publish in the future. And I'm hoping that I have published at least one video where I'm challenging you to create these scripts like this. Actually, we don't need all of this here. We only need this. So we are going to create our own script. So sometimes I give you challenges, other times I don't. So here I don't give you a challenge. So public class axes, and for the axis here, we're going to say public constant string. It's going to be equal to, actually the name is mouse x, and it's going to be equal to mouse x like this. So you see the wisdom again, and this one, copy and paste it. So this is going to be mouse y, and here we're also going to have mouse y. So the wisdom here is that we don't use this hard coding. Instead, we simply say here axis.mouse x, and let me hit enter to move this on a new line. And here, instead of mouse y, we're going to say axis.mouse y. Simple as that. So you see the wisdom. The thing here, and I've explained this multiple times, which I hope that you understand, and I'm talking in vain, but it's better to talk, better safe than sorry. This will make your code bug-free in terms of, if you need to write this mouse x multiple times in your code, so if you need to write this in, I don't know, 10 lines of code or 20 or 30 on different scripts, it can happen that you make a mistake. Maybe you type somewhere mouse like this, so not mouse, or you type mouse or something like that, and you make a mistake. Then you will have a problem in your code, and you need to go and debug it, and it can be a pain, and so on and so forth. So here you put it all in a single place. So if you use this code, if you use this, I don't know, in 30 places in your project, and you have an error, you only need to go back here and change that, and the problem will be fixed. So you get my point. Moving forward, we have the deposition. The next thing to do is normalize it. So deposition.normalize. And here, what I'm going to do, let me hover over. Can I hover over? No, I mean, I can, but it does not say anything. So here, I'm going to say vector3. We have here project on plane. This is what we're going to use in a moment. And here, we're going to say normalize like this. And what is normalize? And I'm teaching you like this to, so you go to documentation and take a look at these things, because most of the things you can learn like this, just simply going and seeing what they are. So when normalize, the vector keeps the same direction, but its length is equal to 1. Basically, we're just making this vector not go crazy. So we're setting the length to be 1, but it's keeping the direction where we need to go, because that's what's important. The important thing is that we keep the direction. So here we normalize it. The next thing to do is take the deposition and multiply that with the move speed, and we're going to multiply that with the time fixed delta time. So here it is. You see, fixed delta time is the interval in seconds at which physics and other fixed frame rate updates like mono behavior fixed update are performed. So this is not delta time. Delta time is frame dependent. Basically, delta time is the difference between each frame, but fixed delta time is already fixed. And where you can fix it, well, you can go here under edit, and then you can go under project settings here, and voila. So let me just see, it's under time, fixed time step. Here it is. So it's 0.02, and you can change this. And basically, that's the fixed time step that you can use to control the fixed update or fixed time dot delta time, or fixed dot time dot fixed delta time. Anyways, we're gonna multiply the deposition with the move speed, and that to smooth it out. And the next thing to do is deposition is gonna be equal to quaternion dot Euler, and what we are gonna do here is 0f for the x-axis, because we're not gonna rotate our game object on the x-axis. But here we're gonna say camera main. So camera.main.transform.Euler angles.y for the y-axis, and here I'm going to say 0f, and we are going to multiply that again with the deposition. This is going to rotate our game object properly relative to the camera's y position. Now, of course, or actually relative to the camera y rotation. Now, of course, one thing that I don't like is using this camera main. It will access the main camera, blah, blah, blah. Instead, what we can do is go here, and right below our deposition, we're going to say private camera. I'm not going to call it main cam. And in the awake, I'm going to say main cam is equal to camera.main. So this camera main, if I hover over the first enabled camera tagged with the main camera, by default, your cameras are tagged. If I click on the camera, by default, the camera will be tagged by main camera. So it's a built-in tag when you create a new project, so don't worry about that. And here, instead of using all of this, what we can simply say now is main cam transform Euler angles, and this will rotate. So multiplying that with the deposition, it will rotate properly our game object in respect to the main camera transform. Euler angles basically the rotation Y of the camera. So what is the next thing to do? The next thing to do is move our game object. So we're going to say RB rigid body move position, and this is going to move our game object, and we're simply going to say here RB dot position, so the current position, and we're going to say plus the D position, which is our delta position that we have calculated with all of these things that we did so far. And here simply we're going to test if our D position is not equal to vector 3, 0. So if it's not equal to vector 3, 0, meaning we have input here, so we are moving our mouse, we have input, what we're going to do is we're going to say target forward is going to be equal to vector 3 dot project on plane. So you see here, projects a vector onto a plane defined by normal orthogonal to the plane. So if I go here, and what we're going to do is we're going to say negative D position, and I'm going to say here vector 3 dot up. Why the negative D position? Well, because our model is created, I don't know how this is created, in a way that our forward, you see the blue axis is pointing backwards. So the forward of the sheep is pointing, let me just open the sheep, yeah. For some reason, the forward is pointing, I believe this has something to do with the 3D model, how it is exported. Basically, when we project it on plane by using this negative D position and vector 3 up, it will calculate, or it will make this blue axis, this blue arrow, the forward, be in this direction. So it will make it be in this direction where I'm drawing now. Basically, it will make the sheep face the direction where it is going. Now, if you are gonna ask me, how do I know that this is doing that? I have no idea. I search it online, because when I don't know how to do things, I search it online, and I plan to do videos in that sense to show you how I debug my projects, how I do this, how I do that. But yeah, basically, no, but all jokes aside, but I plan to do that because, you know, I cannot explain how this works behind the scenes because I don't know, but I do know that it will make it happen. So it will make what I just said happen. So it will, this forward will be forward. Now, before we actually test this out, what I'm going to do is I'm going to right click here and create an empty game object. This one is going to be our camera rig. Now, this is going to be the parent for the camera, and I'm going to set the position X, Y, and Z to 0, 0, and 0. The next thing that I'm going to do is I'm going to take the main camera and I'm going to put it as a child of that camera rig. And I'm also going to reset its position to 0, 0, 0. And this is what we see now. Now, don't worry about that, because the first thing that we're going to do is take the rotation X here, and I'm going to set it at 30. And the rotation Y is going to be at 46, like this. Now, when it comes to the main camera, everything is going to be at 0, 0, 0, or actually 0, 0, except, and also take the rotation 0 and 0. So set the rotation, oh, what did I do? Select the main camera, excuse me. So camera rig will be at X rotation 30 and Y rotation 46. But the camera child, the main camera child, we're going to set the Z axis of it at negative 500 like this. But don't worry, we don't see everything. You see, it's like this, too far away. What we're going to do is change this perspective to orthographic. So now we see it, as you can see. And the size, we're going to change it from 5 to 18. And now we see it even better. So voila, yeah, this is everything we need to do. And now, if I click on the play button, so what we're going to do is, if I click, you see, with the mouse, so I'm clicking with the mouse and I'm moving slowly. So I'm slowly moving my sheep, and I'm moving the mouse. You see the sheep is moving. Let me take the scene here and let me zoom on it so we can see the sheep. So pay attention now. I press the left mouse click and now I'm moving. So what's happening here? Yeah, I pressed it now and I'm moving it. You see how the sheep is moving. You see the sheep is moving, following my mouse, rotating, and it all happens because of this code right here. Now, this right here we explained, and transform forward, we also explained that we're basically moving this forward to the target forward that we are setting right here because of, we need to do all of this because you saw that sheep has that, you know, I've explained it. So basically what's happening here is if we can move, when we hold the left mouse button key, we are gonna say for our D position, input get axis raw, mouse axis. Basically, this will get us the raw. What is raw? This will either return 1, 0, or -1. If it's in the left side, because it's X, it will return -1. If it's on the right side, because it's X-axis, this is Unity's coordinate system. I mean, I talk about this a lot, and I think you know it. So this is Unity's coordinate system. This is Y right here, and this is X right here. And forward, you see forward like this, is Z-axis. But here for the Z-axis, we're actually using the mouse Y. So if we move it up, that means we are going forward. If we move it down, that means we are going backwards. Now, we are getting this axis raw will return either -1, 0, or 1, depending on if we are left or right on the X, or we are not moving at all, or if we are moving up or down, depending on the Y. So up is positive, down is negative. So when we press and hold the left mouse button and we move the mouse left and right, it will detect these right here. Then we will normalize it. Basically, we will set the length of it to be 1, but we will keep the direction. The direction is important where we want to go. The next thing, we're gonna multiply that with the movement speed and smooth it out with the fixed delta time. Next, we are gonna make sure it rotates properly in respect to the main camera's Y angle. Now, of course, we set that to be equal to, Y it's equal to 0, but it's in respect to the camera's main angle, so yeah, it's rotating in respect to the camera. The next thing that we're gonna do is we're gonna use the rigid body move position, moves the rigid body to position. So it will simply move the rigid body to the desired position. And where we are moving it? Well, we're using the current position plus the offset. Basically, think of this D position or delta position as the offset, so it will continue to move it. And then we need to make sure that our target forward is facing the forward, so we rotate properly. And we do that by testing if D position is not equal to vector 3, 0. Vector 3, 0 is 0 for all 3 axes. And if that is not the case, then we're gonna say target forward, project on plane, and negative here. We're using negative because if I hover over here, what will happen? So if I hover over, and if I click now, you see I'm moving to the left side, but it's rotating to the right. I'm moving to the right, but it's rotating to the left. I'm moving up, but it rotates down. I'm moving down, it rotates up. That is the reason why we're setting the negative. Again, that is all because of the messed up coordinates for X and Y for forward, that is for the 3D model. But we fix it like this and it is working. That is the most important part. Moving forward, the next thing that we can do is create the camera follow script. So go back here in Unity and right click inside of the scripts folder, go under create and create a new folder for camera scripts. And inside of this one, right click and go here and create a C# script. This one's gonna be camera follow. And what's important to do here is select the camera rig and attach the camera follow script on the camera rig. So I'm gonna double click here and go here and class tag it like this. By the way, I like to explain things in depth. If that is something that you guys don't like because it makes the videos a little bit larger, not that larger, but let's say for 20%, if the video should be, I don't know, 1 hour, it will be 1 hour and 20 minutes, for example. If you don't like, I can go through everything quickly, but yeah, then you will need to figure out on your own how things work if the explanation is not that good. But anyways, it's your preference, whatever you want. Now inside of the camera follow script, mount of behavior, smash the like button, by the way. And here we're gonna say public float move smoothing, and I'm gonna set this to be 10 by default. I'm also gonna have a public float, and this one is gonna be rotation smoothing, so rotation smoothing. And ng, it's gonna be equal to 15f. Now we are also gonna have here a private transform that we are gonna follow, so transform, which is going to be the target, which is actually our player. And we are also gonna have the target, so private vector 3, and this one's gonna be target forward. So what are we gonna do to get all of these references? Well, first of all, in the wake function, we are gonna say target is gonna be equal to game object find with tag, passing here the player tag dot transform, but we don't have it, so we need to go here in our tag manager and we need to create public class, actually tags like this. And here we're gonna have a public constant string player tag, which is gonna be equal to player. So make sure that these names here, so for example, player and the tag inside of Unity right here, they match up. Of course, for this one, it will because it's default here, capital P. But for your own tags, make sure that that matches. And here we're simply going to say tags.player tag, and it will get us the player tag or the game object who has a tag player in the game, and it will return it. And we're going to say dot transform and get the transform property. Now in the start function, let me just remove this from here. In the start function, we are going to say target forward is going to be equal to transform.forward. And below we're going to say target forward dot y is going to be equal to 0f. And here we're going to call a function snap like this. Now, of course, we did not create it. So right here below our update, we're going to say void snap. Now inside of this function, we're gonna snap to the player's position. So for example, if I go here and I don't know, let's say the camera rig is, let's say at this position. So pay attention what we see in the game. This is where the camera is. When we run the game and we call the snap, it will snap it like this, bam. It will snap it where the player is. And for that, we're gonna say if our target is not equal to null, meaning we have our target, which is actually our player, then we're going to say transform position, which is the position of the camera, is going to be equal to the target dot position, which will set the camera to the position where the player is. Now below we're going to say vector3 forward, which is going to be equal to target forward, and we're going to say forward dot y is going to be equal to transform forward y like this, and below simply say transform dot forward is equal to forward. Now in order to test this out, we can simply go here in Unity and I can take the camera rig and I don't know, I can set it at 1000 where I set it before. And if I hit the play button now inside of Unity, so hit the play button, you see it will snap it where the player's position is. We don't necessarily need to do this, but hey, it does not hurt if you know a thing or two how to. Maybe you need this for some of your games. So yeah, moving forward, we are going to create a void follow, so follow player function. And inside of this one, we are gonna follow the player. That's what the function name is. So follow player, and here we are gonna say if our target is not equal to null. This means we're comparing or we are testing if the target is not null, which means we got a reference to the target here. If we destroy the player by using destroy game object, or if we mess up this tag and we don't get the player, we will have a null reference exception. So this is like protecting you from errors, but of course you will need to fix this if this returns true, or actually if this returns false, which means the target is equal to null, then you have a problem, your game will be broken and you will need to fix it. So anyways, if the target is not null, meaning we have a target or our player, then we are going to say transform that position, which is the position of the camera, is going to be equal to vector3 dot lerp, and we are going to lerp from the transform position, which is the position of the camera, towards the target dot position in the time, delta time multiplied with move smoothing. Now, what is lerp again? Well, lerp, why are you doing this to me? So lerp, why? Yeah, I need to figure out how to, for some reason it is highlighting things. Okay, now it's not. Anyways, I don't know what just happened. Don't even ask me. This lerp will do the following. It will go from one point to another point. So from point A to point B. So it will go from here to here in this time interval. This is what is happening here. So it will lerp or slowly go towards that position. Now below, we are simply going to say vector3 forward again. So forward is equal to transform that forward. And below we are going to say forward dot y is going to be equal to 0. This is to set the y position of our camera. And here we're going to say forward is going to be equal to vector3 slurp. And we are going to slurp from forward, target forward, like this in the time dot delta time multiplied with a rotation smoothing, and below we're simply going to say forward y is going to be equal to transform forward y, and below simply transform dot forward is equal to forward. Simple as that. This will make sure that our y-axis for the camera will stay relevant to the player, because if I go back here, let me just select the player. So player's y position is 0 and camera's y position will be 0. But if the player's position y is, for example, 10, see if it's 10, for example, and we set the camera, let me just take a look at here. If I set the camera at 10, so yeah, it will be relevant to the sheep's y position, meaning it will follow it correctly all the way. So if I go here and hit the play button, we will first snap the camera, and let me zoom in just a little bit because this is how our game is. You see the camera is following. And if I go here, you see I'm moving, so I am moving the sheep, okay? You see I'm moving, the sheep is moving, you see? It is moving and moving and moving, so let's try to move it even more. And the camera is following, you see my point, the camera is following. So yeah, simple camera follow script, nothing new. Maybe the code will change, but we do this most of the time. So yeah, I also expect you to do these things. But anyways, this is how we can make the camera follow the player. Alrighty then, let's move forward. The next thing that we are now gonna do is start moving these platforms. So the first one is this one right here, same as what we saw in the preview. So this is the moving platform, or actually the entrance platform, and it's gonna move right here, bam. And this is how it is gonna go down. But for that, we need to go here in the project, scripts, and right click here and create a new folder. And this one is going to be our platform script, like this. And inside of this one, I am gonna right click and go here under new C# script, and I'm gonna call this one moving. So moving platform, like this. And we are gonna select the entrance platform and attach this moving platform script on it. And ooh, did you see this? From the first try, it worked, because usually it does not work. And if you follow my tutorials, you know what I'm talking about. So this is going to be the script that we're going to use to move these platforms. So we are going to be able to move them from one place to another. We will see that same as what we saw in the preview. So what do we need right here? Well, first of all, we need a serialized field, which is going to be a private transform. This is going to be our move point, or where we are going to move these platforms. Now, the next thing is our private vector 3, so private vector 3, and this one is going to be our start position, so that we can save this position. Because of some platforms, we're going to move them to the move point, and we are also going to move them back, depending on the level. We also need here to create a serialized field for a private float smooth movement. And it's going to be 0.3f, and I made a mistake here, so it's FLOAT, not FLAOT. And we also need a private float initial movement. This is so that we movement M-A-N-T. I have spelling problems, so you already know that. I'm, not myself. Anyways, we need this so that we can determine how fast we're gonna move, and I set it to be serialized field because it's private. This will make it visible in the inspector panel. We can still change it even though it's not public. Now we also need our smooth, so private bool smooth movement halved. This is going to tell us if we divided the smooth movement by 2, because when we reach a certain point, when the platform gets close to its destination, we're gonna halve the speed. We are also going to say here private bool can underscore move to determine if we can move or not. We're also going to say here private bool move to initial. This is going to be activated when we want to move the platform back from this move point to its initial position. Now also here we are going to create a serialized field. This one is going to be private float half distance, which is going to be equal to 15f, like this. And we also need, again, a serialized field, because I'm making these variables private. We don't want them to be accessible in other scripts. That's why we're making them private. And this is going to be our private bool activate movement in start. If this is active, then we will move or we will activate the movement in start. We will see that in a moment, so don't worry about that. We're also gonna have here a serialized field, a private float timer, which by default I'm gonna say is equal to 1f. And that's about it what we need so far. We will have some other variables, but yeah, we will see how that goes. Now here in the awake function, we are going to set the start position. So start position is equal to the transform dot position. This is the initial position of our game object or the platform. We are also going to say here initial movement is going to be equal to smooth movement. This is basically the speed. So initial movement speed by smooth movement speed. And voila, that is that. Now inside of the start function, of course, here we will have more variables. So here add sound and so on and so forth, activate doors. So here activate doors, we'll see that. And in the start function, let me just remove this comment. We are gonna test if activate movement in start, we are gonna call a function that will activate. So we are gonna say here invoke like this, and in codes, because we're gonna call a function name, and it's gonna be activate movement like this, and we're gonna call it in the timer, so it's actually timer like this. This activate movement function is going to be the function that we are gonna activate, well, if this is true. And let me just create it here quickly. So it's going to be void activate movement. And here simply what's going to happen is that we're going to say can move is equal to true, and we're going to start moving. And of course here we're going to play sound effects and rotate game object, so rotate. But we will see that in a moment, because first we do need to create that function to move our game object. So here we're going to say void move platform, and this one is gonna be responsible for moving the platform. And in the update function, we're gonna call it move platform like this. And let me just remove this update or this comment from the update. So here we're gonna say move platform. Now inside of move platform, we're gonna test if can move. So if can move, meaning we are able to move. So if we can move, then everything is gonna happen. Otherwise, it's not gonna happen, because if we cannot move, well, we can't move, we are frozen. And we're gonna say here transform position is gonna be equal to vector3 that move towards. And you see this move towards will move the game object from the position, so it will move it from the transform position towards the move point, that position in time interval, which is the smooth movement. Now again, it's similar to slurp. So basically what it's gonna do is we have here point A, and here we have point B like this, and it's gonna move from A to B in this time interval. Simple as that. Now, my advice is that you don't need to know how these functions work behind the scenes, because it does its purpose. It will move from one point to another. That's all you need to know. How does it calculate everything? That's not important to you. So it will move from the transform position towards the move point, that position. And here we're gonna test if our vector3 distance, so if the distance from the transform position, which is the current position of the platform, and the move point, that position, so if the position distance from our current position of the platform and towards the move point or the target or the final destination, if that distance is less than or equal to half distance, and this is why we are using this variable half distance. Basically, when the distance between the platform and its target destination, so the move point, is less than or equal to 15, then we are going to halve the speed. But first here we need to check if we did not, so if smooth movement is not halved. You see here, if smooth movement, pay attention, we have the exclamation mark, which will make what's after it the opposite. Which means if this smooth movement half is false, this will make it the opposite, which is true, which means, I already said it, it will make it the opposite, which is true. So essentially here we're asking if we did not have the smooth movement value, then we're gonna say here smooth movement divide equal to by 2. This is a shortcut for writing smooth movement is equal to smooth movement divided by 2. Basically, it's just a shortcut. So here we're dividing by 2, and we're telling now smooth movement half is equal to true, because we don't want this to be executed again, so that we don't half it, because every single time this runs in the update function. An update function runs every frame. And if we don't control it like this with a Boolean variable, and it will be called 3,000 times probably. Now, outside of this distance, we are also going to test if vector3.distance from the transform position, which is the platform position, towards the move point position, if that distance is equal to 0, meaning the platform has reached its destination, then we are going to say here can move is equal to false, because we don't need to move anymore. Here we're going to say if smooth movement half, if we halved the value of our smooth movement, we are going to say smooth movement is equal to initial movement, because we need to reset the value in the case we need to move the platform back to its initial position. And here we're also going to say smooth movement half is now equal to false, so that this line of code gets executed one more time. So the next thing here that we're gonna do, we're gonna deactivate doors. So here, deactivate doors, like this, doors. And here we are gonna stop playing the sound FX. Basically, we have everything we need to start testing this. And this is gonna be actually a public void, because we're also gonna be able to call this from within other scripts. Now, if you pay attention here, if activate movement in start is true, we're gonna invoke the timer, which is gonna start moving the platform. So if I go back here, and we have the platform, you see we have this platform here, and if I click here, activate movement in start, if I check that checkbox, and if I hit the play button, pay attention, I'm gonna go in the scene, you see after 1 minute, or actually, excuse me, it's a very good idea to have a move point that you need to attach when you want to move it, because here, pay attention, you see unassigned reference. If I double click it, you see transform position, it's pointing here to the move point position, because I did not attach it. So what we need to do is go here and right click and create an empty game object, and I'm gonna call this one move point 1. So move point 1, and the position of it is gonna be 5.5 for the X. For the Y, it's gonna be 0, and for the Z, it's gonna be 0. Simple as that, and I'm gonna go here and mark it with this orange tag. So this is the move point where we need to go, and we need to select the entrance platform and attach that move point. So drag and drop the move point right here, and now everything is cool. So if I hit the play button now and go inside of the scene, pay attention now, you see the platform is moving. You see the platform is moving, it's going towards its direction, and it will reach that direction. Now for this entrance platform, it's at 100 for the X. So let me just take the sheep and set it 100 for the X. Where is the sheepy? Come on, sheep. Okay, here it is. So what are we gonna do now is that we are gonna run our game, and you're gonna see one thing. So I'm gonna hit the play button, our sheep is on the movement platform, and the platform went and the sheep fell down, and what the hell is going on? Teacher, why are you doing this? Why is this sheep bouncing up and down? Well, let me stop you right there. Don't ask all of these questions. What we need to do is we need to take the sheep and set it as a child of the entrance platform. Now, don't go here and set override. Don't do that. We don't want to do that. Also for the sheep, don't do that. We don't want to do that. Instead, simply leave it like that, because it needs to be a child of this platform. And I'm also going to take the sheep and rotate it. So it's going to be rotated, 90 degrees. So 90 degrees so that the sheep is looking towards this direction. Because now when the sheep is a child of the platform, when the platform moves, the sheep will move along with it. So I'm going to hit the play button, pay attention now, and the platform is moving. You see it is moving, and it will reach the destination, and voila, we can start our game. But we have one problem. If I try to move the sheep, I'm not able to do it. The reason for that is because of these doors. So if I go here, you see entrance platform, I have this small, you see these doorways, you see these are all colliders. Now I have them set to their box colliders solid, they're not triggers. If I set them to be a trigger, we will be able to pass through them. And also for this platform as well. Let me select it. This is the large platform. So let me just find, here it is. We have this wall here. We have the doorway. Also, we need to check this one as a trigger as well. So now if I go back here, we will be able to move. Now, the reason why we have these doors is because we're not going to allow our sheep to move outside of these bounds, as you can see. So it's not going to be able to move outside of these bounds. But you see, it's, well, for our game, it's a little bit, you know, tricky. There are two ways. There are ways. How can we fix this? You can go, before you run the game, you see, you can select that doorway. You can make it a trigger. So is trigger. We are going to check the trigger for this one. We can do the same thing for this one right here. Let me select it. Here it is. So we can do the same thing for this one, but we can also go here and platform script, and I can go and C# script. And this one is the door controller. And what I can do is I can select the entrance platform, and I can attach this door controller on it. And I can double click here, and I can get a reference to all of these doors. So I can say here private transform array, and this is going to be children. And inside of the start function, and here I'm also going to say serialize field. This one is going to be bool deactivate in start. We will see for what you're going to do this. Don't worry about that. I'm going to remove the comment from here. And here what we can say is children. So children is equal to transform dot get component in children, or get components with S, plural, not singular. And those components are going to be transform components, which means it will go into the children of this transform. And this transform is, if I go here in Unity, it's the entrance platform. It will go through all of its children. So the small platform, the floor, the door, through all of these, and it will get all the transforms. Now, what we can do here, instead of the update, I can create something like public void. So public void open door, like this, or open doors, because it's a plural. It's plural, not singular. And here we can simply say for each, and this is like a for loop, which means it will loop through every transform C in children. So for every transform, and the name C is the name of the variable, so it will count for every variable in that iteration. If we have thousands of children, it will go through 1, 2, 3, 4, up to the last one. And during that iteration, this C will be referring to the current transform in that iteration. So if it's the first iteration, it will be referring to the first transform in this array. If it's the second, then it will be referring to the second transform in this array. So what we're going to do here is we're going to say if c.compare tag, and we're going to compare it to tags dot door tag, so door underscore tag, and if that is true, we're simply going to say c.gameObject dot get component, and we're going to say here collider dot is trigger is equal to true. So this will also work, but we need to create this door tag. So I'm going to go here in the tag manager. We have the player tag. I'm simply going to copy it, and here I'm going to say door tag. So door tag, and here for the player, I'm simply going to say door. Now, in order to deactivate that, what we simply need to do is go and create this tag. So door